Welcome friends to my channel. Now on last lecture I have introduced the concept of viscosity and viscous force. Okay, and also I have obtained the dimensions of viscosity. Now in today's lecture we shall going to discuss the streamline and turbulent motion of liquid. Okay, first of all, streamline motion. Now the motion of a liquid may be either steady or unsteady. Okay, so if the motion is steady, that is the liquid follows a regular and definite path. Okay, the liquid follow a regular and definite path, and uh, magnitude and direction of velocity at every point remains same, then the corresponding motion is known as the streamline motion. Okay, so magnitude and direction of velocity at every point remains same, and the liquid follows a definite path, then the corresponding motion is known as the streamline motion. That is, velocity will remain same at every point. Okay, and from this figure you can see that the liquid follows a definite and regular path. So this type of motion is known as the streamline motion. Okay, so this is called streamline motion. This is called streamline motion. Okay, this is called streamline motion. Okay, now what is turbulent motion? Now another type of motion is turbulent motion. This is opposite to streamline motion. That means here the magnitude of velocity does not remains constant at every point, and also the liquid do not follow a definite path. Okay, the magnitude of velocity at every point does not remains same. The magnitude of velocity at every point does not remain same, and the liquid does not follow a regular path. Okay, so this type of motion is known as the turbulent motion. Okay, so there are two types of motion of a liquid. Okay, now this is what about streamline and streamline motion and turbulent motion. Okay, now another important term that we have to associate is that the critical velocity. Critical velocity of a liquid. So what is critical velocity? Now it is the velocity up to which the motion is streamlined, and beyond this the motion is no longer streamlined but becomes turbulent. Okay, so if this is critical velocity, then up to this the motion is streamline, and beyond this the motion becomes turbulent. Okay, so maximum velocity of the liquid up to which the motion is streamline is called critical velocity of liquid. Okay, critical velocity of liquid, and beyond this the motion becomes turbulent, and beyond this velocity the motion becomes turbulent. Okay, so this is the definition of critical velocity. Okay, now critical velocity is related with coefficient of viscosity by this relation k into eta by rho r, where eta is the coefficient of viscosity, rho is the density of liquid, and r is the radius of the tube through which the liquid flows, and k is constant known as Reynolds number. Okay, k is a constant called Reynolds number. K is called Reynolds number. Okay, so critical velocity and coefficient of viscosity is related by this relation. Eta is coefficient of viscosity, rho is the density of liquid, and r radius of the tube. Okay, now let us justify this formula. Okay, that is, let us check whether this formula is right or not. Okay, just by using the dimensional analysis. Okay, by using the method of dimension. Okay, say eta to the power x, rho to the power y, r to the power z. Just we simply write this in dimensional way. Now if we write it in dimensional way, then this is velocity, that means lt to the power minus 1. Okay, this is coefficient of viscosity, ml to the power minus 1, t to the power minus 1. Rho, that means ml to the power minus 3, and r is this. Okay, this is m to the power x plus y, l to the power minus x minus 3y plus z. Okay, and simply t to the power minus x. Okay, now if we compare both sides the dimension, then we see that x equals to 1. Okay, and x plus y is 0, that means y equals to minus x, this means minus 1, and minus x minus 3y plus z, this equals to 1, that means z equals to 1 plus x plus 3y, that means 1 plus 1, this is minus 3, that means minus 1. Okay, x1, y minus 1, z minus 1. Now if we substitute these values in this equation, then what we get? We get x1, this is 1, y minus 1, and z minus 1. So we see that k into eta by rho r. Okay, so this formula is correct, and we prove it by using the method of dimension. Now k is a constant known as Reynolds number, and for a narrow tube, in this chapter we are mainly confined with the narrow tubes. Okay, so for a narrow tube k is approximately 1000. For a narrow tube the value of k is approximately 1000. Okay, so in our today's lecture I shall discuss about the different motions, streamline and turbulent motions of liquid, critical velocity and Reynolds number. Okay, now in our next class we shall going to discuss few other issues related to viscosity. So if you don't subscribe my channel, then kindly subscribe it to get latest videos. Okay, thank you.